Welcome. My presentation is titled Combination of Machine Learning Technique and Variable Rate Application to Optimize Nitrogen Application. Europe has set itself the goal of becoming the first carbon-neutral continent by 2050. To achieve this, it has set minimum thresholds. For example, reduce the use of mineral nitrogen fertilizers by 2030 in 20%. With this goal in mind, this paper will assess the capacity of the variable rate fertilization technique to reduce the use of fertilizers without decreasing yields. But first of all, what is variable rate fertilization? Variable rate fertilization in precision agriculture refers to the application of fertilizer at the precise location or considering the requirements of the crop. For example, in wheat, the fertilizer dose is set taking into account the estimated final yield. Figure 1 shows a yield map. In the green zone, the yield was higher than in red zone. If a uniform dose of fertilizer was applied, as in figure 2, in the less productive areas the crop did not use all the fertilizer and a part may be lost. However, if the plot was fertilized with the variable rate fertilization technique, as in figure 3, the fertilization would be better adjusted to crop needs. But, to create a fertilization map, the first step is to estimate the yield of the plot. For the plot where the variable rate fertilization technique marked in red was to be tested, no yield information was available. This plot's yield was estimated using a regression algorithm based on machine learning. For this purpose, yield, elevation and NDVI data from 13 plots, in green, were used. Using 70% of the available data, a total of 15 different models were trained. The 5 algorithms that have the best ability to predict yield are highlighted in green. These 5 algorithms were subsequently validated using the remaining 30% of the data. And the algorithm with the best results was the random forest. In order to know a little about the study plot, it covers an area of 12 hectares. Due to its morphology, it has flat areas with deep soils and areas with steep slopes with shallow soil depth. The first step was to run the previously trained algorithm over this plot. Then, the plot was divided into 4 production zones. In the second step, the prediction map was compared against the production image provided by the farmer. It can be seen that both images are similar. Finally, together with the farmer, and based on the estimated yield map and his knowledge, a fertilizer prescription map was designed adjusting the dose to crop requirements. Then, this map was introduced to the tractor monitor and this plot was fertilized using this map as a guide. After all these processes, the most important thing comes at the end, the results. The left side of the table shows the homogeneous fertilization scheme followed in 2019, while the right side of the table shows the fertilization scheme followed for 2020. Here you can see the dose assigned to each zone. Finally, the red color shows the total amount of nitrogen applied to the plot. During 2019 year, a total of 1,345 kilograms of nitrogen were applied. While in 2020 this amount was reduced to 1,064 kilograms. This represents a reduction of 20%, reaching the requirements set by the European Union. Moreover, the farmer confirmed that there had been no significant reduction in production. In resume, and in a very summarized way, the 2 main conclusions obtained in the work are: 1. The variable rate fertilization technique allows to adjust the nitrogen fertilization to crop nutritional requirements. 2. Machine learning regression algorithms with information extracted from vegetation index and digital elevation models can help to estimate yield. And finally, thank you very much for your attention.